Have you ever actually stopped to think about the absolute immense stakes involved in aerospace manufacturing? I mean, we are talking about an industry where a single microscopic fracture or just miscalculating a fraction of a millimeter can literally mean the difference between a totally successful flight and an absolute disaster. We're talking tolerances thinner than a human hair. But before that metal is even cut, there's another equally high-stakes calculation happening completely behind the scenes, and that is the business calculation. So welcome to this explainer. Today, we're going to unpack the hidden business mechanics of the aerospace industry by looking at a genuinely fascinating job specification from Petrus Technologies. They're a company right at the cutting edge of precision engineering. We're going to explore the absolutely critical role that makes this entire industry financially viable.
So, how do you accurately price a high-precision aircraft engine component before a single machine is turned on? It is a massive, incredibly complex puzzle. You've got volatile raw material markets, crazy expensive machinery, highly specialized labor, and strictly enforced aerospace quality standards. If you guess too low, well, the company loses money on every single part. But guess too high, and boom, you lose the contract to a competitor. The ultimate solution to balancing those skyrocketing aerospace costs and ensuring profitability actually sits squarely on the shoulders of one very specific professional, and that's the estimation engineer. Section 1, the aerospace estimation role, the linchpin of precision manufacturing. Okay, let's dive into this. An estimation engineer at a company like Petrus Technologies evaluates all the production costs, the machining requirements, material expenses, and the processes. And they do all of this before production even begins. Actually, think of this person as a literal modern-day industrial alchemist. They are tasked with looking at a flat two-dimensional engineering drawing and figuring out exactly how to turn raw aerospace-grade metal into a highly profitable business model. It requires a kind of mind that can simultaneously visualize complex 3D machining operations while calculating cold, hard, real-world economics. Section 2. Mastering manufacturing costs. The economics of aerospace. Let's zoom in on the daily mechanics of this role and that constant, everyday battle against tight tolerances and strict budgets. An estimator is basically always balancing two massive pillars of manufacturing economics. First up, material costs. Now, this isn't just buying a hunk of steel, right? In aerospace, it's about selecting highly specialized alloys, calculating exact utilization, and crucially, figuring out wastage and scrap calculation. If you are carving a complex engine component out of a solid block of titanium, the scrap left over is still highly valuable, and that has to be factored right back into the price. Then you have labor and overheads. The estimation engineer has to calculate exactly how many hours of highly skilled labor are required, plus the massive overhead of running million-dollar machines. Literally every gram of scrap and every single second of labor must be meticulously calculated for these high-accuracy mechanical assemblies.
And this brilliantly illustrates how those specific cost pillars combine to form the absolute baseline of a customer quotation. It's essentially split into three main slices: material cost, machining time, and labor, and overheads. If an estimation engineer misjudges the size of any of these pieces, based on a customer's request for quotation, the entire financial viability of a multi-year aerospace contract could be in serious jeopardy. It is a balancing act of extreme precision. Section 3, machining and cycle times. Calculating every second. Let's shift our focus to the realities of the shop floor for a second. Imagine a top-tier aerospace customer needs a really complex, precision part for a brand new aircraft. As the estimation engineer, you look at the blueprint. You have to break that part down into highly specific operations: CNC turning, CNC milling, drilling, grinding, maybe complex multi-axis machining. For every single one of these, you have to calculate the exact cycle time, meaning exactly how long that cutting tool takes to do its job. Why? Because that cycle time directly determines your production cost and it dictates your delivery schedules. Think about it, an error of just 30 seconds on a machining cycle multiplied by 10,000 parts, yeah, that can completely destroy a production timeline and absolutely wipe out a profit margin. Section 4, navigating special processes, beyond basic machining. But wait, an aerospace part isn't finished just because the metal has been cut. The sheer technical breadth required for this role is staggering. Just think about the special processes an estimator must understand and, more importantly, price out. You've got heat treatment to harden the metal, anodizing and passivation for corrosion resistance, shot peening for fatigue strength, and then NDT, or non-destructive testing, to ensure there are absolutely no internal microcracks without actually breaking the part. Plus EDM, plating, surface finishing, and welding. You don't just need to know how to cut metal, you need to understand the vast chemistry and physics required to meet these strict aerospace standards, and exactly how much each of those third-party or in-house processes is going to add to the final bill. Let's move to and see how this builds into a cohesive chronological workflow. When a request comes into Petrus Technologies, the path looks exactly like this. Step 1. Review those engineering drawings and request for quotations to grasp the full scope. Step 2. Get really granular and calculate the material and machining cycle times we just talked about. Step 3. Factor in all those special processes, plus inspection and specialized aerospace-grade packaging. And finally, Step 4. Synthesize all of that incredibly dense technical data into a clean, accurate commercial quotation. It is quite literally a process of translating pure engineering into pure business.
Section 5. Your profile and next steps. Are you the alchemist? 3 to 7, that is the specific number of years of practical industrial experience in manufacturing estimation that Petrus Technologies is explicitly looking for. So this is absolutely not an entry-level position where you're just learning on the job. The stakes are way too high for that. They need someone who already has a deep, intuitive understanding of the shop floor, someone who has actually felt the pain of a miscalculated machining cycle, and who brings real, proven expertise to the table. And to back up that experience, the educational profile requires a Bachelor of Engineering or a relevant diploma. Specifically, they are looking for backgrounds in mechanical, production, manufacturing, or aeronautical engineering. This academic foundation, it's absolutely non-negotiable. The estimator must be able to fluently read complex engineering drawings, manage vast bill of materials, and deeply, deeply understand stringent aerospace standards. You literally have to speak the exact language of the engineers who designed the part. But, beyond the hardcore technical CNC knowledge, this role requires a deeply human element. Yes, of course, you need expertise in Excel and strong analytical thinking, but you also need excellent communication skills to coordinate with production, purchasing, and sales. The estimation engineer is basically the central hub. You have to communicate clearly to clarify technical details with customers. You need the confidence to push back when a design feature is just unnecessarily expensive to machine, and you have to work seamlessly with internal teams to optimize costs. You are the bridge between the customer's vision and the shop floor's cold, hard reality. So if everything we've gone through today sounds like your exact skill set, well, Petrus Technologies wants to hear from you. You can take the leap into this crucial role by sending your resume directly to vidya.mani@petrustechnologies.com. Or, if you want, you can learn more about their precision operations at petrustechnologies.com. It really is a chance to be at the very core of aerospace manufacturing. So we're going to leave you with this final provocative thought. Every single time you look up and see a commercial airliner or an advanced jet crossing the sky, just remember that its journey didn't actually start on a runway. It started on a spreadsheet. It was guided by someone who understood exactly how to turn raw metal into the miracle of flight profitably. So, will you be the one to calculate the true cost of taking flight? Thanks so much for joining us for this explainer. Keep learning, and we will catch you next time.